Hello, programmers. Welcome to Programming with Yogi. So, hope you're doing well. Today, we're going to learn selection sort algorithm. So, let's see what is selection sort algorithm. Let's take an example. I have an array with 5 elements. So, my array index starts with 0. Every array index starts with 0. So, this is the 0th index. This is 1, 2, 3, 4. But the size of the array is 5. So initially, I'm going to consider the whole array as unsorted part. In selection sort, we are going to divide this array into sorted part and unsorted part. So the main thing is we have to find the minimum element from the unsorted part and put it in the first position in the unsorted part. So how to find the minimum element? As you can see in the array, 2 is the minimum element. We can directly swap that with the first position. But while writing the code, we cannot directly find that 2 is the minimum element. We have to iterate throughout the array and compare each and every element and decide which one is the smallest one. That's what we are doing here. So initially, I'm considering 20 as the smallest, the min element. I have a variable min element and I store it in that. So I'm going to compare minimum element with the next element. So as 12 is smaller than my current minimum element, I have to update the minimum element as 12. And again, I'm going to compare the minimum element with the next element. So as 10 is smaller than the current minimum element, I'm going to update my minimum element as 10. So I'm going to compare 10 with 15. As 15 is larger, no need to update the min element. Finally, I have to compare 10 with 2. As 2 is smaller than my current min element, I'm going to update min element as 2. So as I have reached end of the array, I can consider that 2 is the minimum element. So that we found the min element. What we have to do with the min element? We have to, as I told you, we have to swap the min element with the first position of unsorted part. So I have swapped 2 and 20. So as 2 is in its right position, I have to consider the first element as sorted part and the remaining elements as unsorted part. The same thing I have to repeat for the unsorted part. I have to find the minimum element in the unsorted part and swap it with the first position of unsorted part. So in the unsorted part, 10 is the minimum element. What I have to do? I have to swap 10 with 12. So I swap 10 and 12. Now my 2 and 10 are sorted parts and remaining are unsorted parts. Again, I have to find the minimum element from the unsorted part. Here you can see 12 is the smallest and it is in the first position of unsorted part. So no need to make any swapping. Again, my sorted part is updated and unsorted part is there. So in unsorted part, again I have to find my minimum element. As 15 is the smallest and it is in the first position of unsorted part, no need to make first position of unsorted part. No need to make any kind of swapping. Now my first 4 elements are sorted. So I'm only left with the last element. So as last element is only one element, there is no need of any comparisons or operations to be done. This is the selection sort algorithm. So in selection sort algorithm, I'm going to loop size minus 1 times because the last element is ignored. As when we iterate size minus 1 times, obviously the last element is going to be in its right place. So set the first unsorted element as the minimum. We have to initially set unsorted one as a minimum. We have to iterate through the remaining elements and we have to consider, we have to compare and we have to update the minimum element. Finally, after coming out of the loop, we are going to get our new minimum element and swap minimum with first unsorted position. Then in the algorithm, all the array will be sorted. Now, let's write some code. Let's implement selection sort in Java. So I'm going to write a selection sort class, public class. So as my file name is selection sort dot one, so selection sort one, and I'm going to write a main method. In this main method, I'm going to take an example of the array. So int, we'll take the same example. Array is equal to 20, 12, 10, 15, 2. So I'm going to call the sort method and passing the array to it. So let me write my sort method. So I have to write a static method. Array, because we are passing the array to it. In sort method, we are passing array as a parameter. So initially, as we are seeing the algorithm here, we have to loop size minus 1 times equal to 0 less than array dot length minus 1 I plus plus. And I have to set the initial element as my minimum. So let's say the min is array of I. Now I'm going to loop over the remaining elements and find the minimum element from it. Remaining elements, that is from I plus 1. Here I'm going to compare the minimum element. So instead of taking minimum element, I'm going to take minimum index, so that there is no extra usage of memory. Here I'm going to compare my I'm going to compare my current element, that is, okay, this is array. I'm going to compare my current element, that is array of j. If it is less than my array at min index, okay, what I have to do, I have to update my min index is equal to j. So finally, after coming out of this loop, I'm going to have my min index. What I have to do, I have to swap array at min index with array at ith position. So let's take a temporary variable, int temp is equal to array of I. Array of I, let's clear this, is equal to, okay, I'm sorry, array of min index, and array of min index is equal to temp. So now my array will be sorted. I'm going to print the array. I've called the function here, the array will be sorted, and I'm going to print the array. So for int I equal to 0, I less than array dot length I plus plus. System dot out dot println, print, just print, because we're not going to print in each line. So array at ith index, and with comma separated, concatenating a comma. Yes, so as you can see, initially we are repeating it for, as you can see, we are repeating length minus 1 times, that is size minus 1 times, and then we are setting a min index, and again we are looping over the remaining elements, that is unsorted part. And if this current element is less than the minimum element we have set initially, then we are going to update the minimum index. And after coming out of the loop, we have our min index. So what we have to do is we have to swap array of I and min index. So this is the swapping logic. So after completing all size minus 1 iterations, our array will be sorted. and we are printing it here. So let's run the code. Hope there are no errors. Okay, I missed it. Array. Yeah, cool. My array is sorted.